Hello everyone, welcome to my channel. In this video, we will learn how to write loops. We will also learn some methods for performing calculations on individual rows or columns of a matrix, and the individual components of vectors or lists. In the last video, we learned how to write a user-defined function. Functions can help us to reduce duplications. Another tool for reducing duplication is iteration. Suppose that we would like to compute the median value for each column of a matrix. Each command for calculating the median value is almost identical, except for the column index. In this situation, we can wrap these commands into a loop to reduce duplications. A common way to construct a loop is to use a for statement. It consists of three components. First, we need to decide where to store the calculated result. Since we are calculating the median value for 3 columns, the results can be stored in a numeric vector of length 3. To create an empty numeric vector, we can use the numeric function. The numeric function creates a numeric vector with a specified length, with each element filled with 0. This step is to ensure allocate sufficient spaces for the output. The second step is generating a sequence. This step determines how many iterations the loop run. During each iteration of the loop, the index variable, such as I, is assigned from 1 to 3. The last step is constructing the loop body. The codes in the loop body run repeatedly, based on the different values of the index variable, I. In this example, since the loop iterates 3 times, the result from calculating the median value from column 1 to column 3 is assigned to each element of the output vector. A better way to count the number of iterations is to use the end-call function. So we don't need to count the number of columns manually. Sometimes we do not know how long the input sequence should run. In this situation, we cannot use a for statement. Instead, we can use a while statement, which consists of a condition and a body. The loop will keep iterating if the condition is evaluated to be true. We can rewrite any for loop with a while loop, but not vice versa. In this example, we rewrite the previous program by using a while statement. Notice that the index variable needs to be initialized first, before the loop starts. Then we need to write a command to increment I within the loop. Once the index variable, I, is incremented to 4, which is greater than the number of columns, the loop condition fails, and the loop stops. In the last video, we wrote a function to impute the missing value of a variable. The function that we wrote can only impute one variable. We can modify this function by letting it take more than one variable. In the second argument of the function, we can change var name to var list, which takes a character vector containing a list of variable names. Then we can write a loop to iterate each element of var list. In the previous example, we started writing a loop by creating an object to store the calculated result. In this example, we do not need to create an object for storing the result, since we can replace the original column from the input data with the vector that contains the imputed values. In the second step, we create a sequence. The number of iterations that the loop run equals the number of provided variables. To construct the loop body, we can reuse the function body of the impute function. We only need to add one statement within the function body, which is extracting each variable name from var list and assigning it to var name. At each iteration, var name is assigned with a different variable name. That's all we need to do for modifying the impute function. Here is an example of generated output by imputing a list of variables. In this section, we will learn how to use apply type function. In R, there are built-in functions to calculate the statistics for each row or each column of a matrix, such as row sums, row means, col sums, and col means. The apply function is a more general operation on each section of a matrix or an array. The first argument can be a matrix or an array. If we provide a data frame, the data frame will be coerced into a matrix before the calculation. The second argument margin is used to specify the calculation that needs to be performed on rows or columns. 1 refers to row, 2 refers to column. The third argument is a function name that can be either a built-in function or a user-defined function. This is the function for performing the calculation for each section of X. For example, if we provide 1 for the margin argument, the calculation is performed at each row. the last argument is a special argument. If we have additional arguments that need to be passed to the function, we can place them at the end. In the previous section, we used a loop to calculate the median value of each column of a matrix. Instead of using a loop, we can also use the apply function. First, we specify the matrix name, M, as the first argument of the apply function. We specify 2 as its second argument, since we are calculating a median value at each column. Lastly, we specify the function name, which is median, as the third argument. If we specify 1 as the second argument, the operation will be performed at each row of the given matrix. In this example, I changed one value in the matrix to a missing value. To use any statistical function on a vector that contains missing values, we need to specify an a.rm option to true. If we are using the apply function, we need to specify the na.rm option to true, as the fourth argument of the apply function. Most functions that we've learned can operate on each element of a vector, but not for a list. We can use lapply or sapply function to perform calculations on an individual component of a list or a vector. Lapply and sapply functions are similar to the apply function, except that they don't have the margin argument. The calculated results from the lapply and sapply functions are the same, except that sapply will simplify the result as a vector or a matrix, if possible, while lapply does not. Lapply will always return the result as a list. The first example lapply function, to calculate the means of each component of a given list. The result that is being returned is a list. On the other hand, using the sapply function, simplifies the result to a vector. Here is an example of utilizing a user-defined function. In this example, we first create a function called mean_sd, which returns the mean and standard deviation of a given vector. Then we use this function in the lapply function. In the first lapply function, we provide the function name, mean_sd. This approach is like what we did for providing a built-in function name, like mean, median, etc. In the second approach, we provide the function body for the lapply function. Most of the time, when we create a user-defined function that is used in an apply type function, we don't need to create this function beforehand. We can simply create this function within the apply type function, like in the second example. This time we use sapply instead of the lapply function. Using the sapply function simplifies the result to a matrix. When we work with a data frame, we can use either apply, lapply, or sapply function. If we use the apply function, R will convert the data frame into a matrix, and then apply the operation. On the other hand, if we use lapply, or sapply function, R will treat the data frame as a list. Remember that a data frame is a special case of the list object. If we want to calculate some statistics for a numeric variable, based on each level of a factor, or a categorical variable, we can use the tapply function. The first argument is a numeric vector. The second argument is one or more factors. The third argument is either a built-in function, or a user-defined function. Like other apply type functions, if we have more arguments that need to be passed to the function, we need to place them after the third argument. We will see some examples of using the tapply function, based on the Quine dataset, from the Mass library. In this data, 146 children from Walgett, New South Wales, Australia, were classified by culture, age, sex, learner status, and the number of days absent from school in a particular school year. Notice that the first 4 variables in this data set are factors, only the last variable days is a numeric variable. The first example calculates the average number of days absent from school for each level of the age group. The days variable is placed in the first argument. The second argument is the factor age. The last argument is the function mean. The second example computes the average days for each level of age and sex factors. When we include more than one factor, we need to group them into a list. Instead of using the tapply function to perform the calculation, we can use split and the sapply function to obtain the same result. The split function split a vector, or a data frame, based on one or more factors into a list. For example, we can split the days variable, based on each level of the age variable. If the object being split is a vector, the result will be a list of vectors. Once we split days by age group, and store the result in a list, we can use the sapply function to calculate the average days for each age group. In this example, we split the days variable by each level of age first. Then we use a user-defined function to calculate the mean and median days for each age group. Notice that the split function is nested as the first argument of the sapply function. In this example, we use a user-defined function to calculate the mean and median value for each level of age and sex. When splitting the data by more than one variable, these variables need to be grouped into a list. Now, let's review what we've learned from this video. In this video, we learned how to construct a loop, which helps us to reduce duplication in code writing. We also learned several apply type functions. We can use the apply function to apply an operation on each section of a matrix or an array. Both sapply and lapply functions apply an operation on each component of a vector or a list. We can use the tapply function to compute statistics of a numeric variable for each level of a categorical variable. I hope you enjoyed this video. Please like and subscribe to my channel, and click the bell icon to get new video updates.